Good morning students, I'm Kumar Sonal, your tutor. Today let's learn about surface area and volume. Let me write it down for you. Surface area and volume. I know many of you are already aware of the formulas, but in this class we will know how these formulas came. So first of all, let us see the main figures which we have to study in this chapter. Number one is our sphere. Then come cube, and if the length, breadth and height are different, then a cuboid. Okay, so cube or cuboid. Next come cone, and the last cylinder. Now if I ask you what is the volume of a sphere, I know that comments will be full of answers, but I'm trying to make you understand that just by remembering formulas it won't work in the future. We have to understand how these formulas came. For example, its volume is 4 by 3 pi r cube, right? See, one sphere is regarded to be equivalent to two cones. For this, you need to understand differentiation, integration, all these things which you will study in your higher classes, not now. So for now, you should understand the basic how this formula came. So for that, let me first of all rub these so that I can get some space for you to make you understand properly. Here, what I'm trying to say is one cone plus another cone is equal to one sphere. The volume of two cones is always equal to the volume of a sphere. Okay. So, what is its volume? We'll come to that point, that how its formula came into existence. But before that, simply jot down its volume. And what is its volume? Pi r square h by 3. Right? Its volume is also pi r square h by 3. But here you should keep in mind that the radius of these cones are equal to the radius of this sphere. One thing more, the height of these two are also equal to the height of this sphere. So exactly what we are calling the height of this sphere is actually its diameter, right? That means here what we have written height is actually the diameter for this sphere. And what is diameter? Diameter is twice the radius. That means we can write it down like this: pi r square 2r, right, by 3. And exactly the same, pi r square 2r by 3. Now we need to solve it further. So here, since both these are same, so we can write it down 2 pi r square 2r by 3. Now here this 2 will come outside and multiply with this 2, so it became 4, and this 3 we can write outside as 3, 4 by 3. And here see, 1r multiplied by r square, then it will become r cube. This is what we have as a volume of a sphere. This is how we get the volume of a sphere. Understood? Now, before we understand the volume of cone, first we need to understand the volume of cylinder. After that only we will be able to understand the volume of this cone. So let me rub it again. See, this is a cylinder, and I need not to ask you the volume because I know that many of you will answer it immediately. But our objective is not that. Our objective is to understand that how these formulas came. So first of all, think about a circle, right? And we all know the area of circle is pi r square, right? Now how this formula came, we need to understand differentiation, integration, all those things. So for now, just focus on this formula, pi r square. What type of figure is this? It is a two-dimensional figure, right? But cylinder is a three-dimensional figure. So to make it a three-dimensional figure, we must have height. I'm drawing it downwards because see, in upwards I don't have a space, that's why. So I am drawing it downwards. Now it became a three-dimensional figure. Here we also have height. Multiply this height with this. This is the volume of cylinder, right? Now we'll jump into the cone. So let us quickly draw a cone. Now focus on this figure properly. you will see an invisible cylinder. See, we have an invisible cylinder here, but in a different form, which has become a cone now, right? That means if from the volume of this cylinder we remove these parts, then the remaining will be the volume of the cone. And it is said that a cylinder is 3 times a cone. What does that mean? That means if in a cylinder we divide 3, we get a cone. And this is the volume of the cone. Now let us quickly move towards cube and cuboid. But I believe that by understanding one, you will understand the other. Let me draw a cuboid for you. It's a cuboid, right? Now recall one two-dimensional figure which is like this. You recognized it correctly. It is a rectangle, right? And we all know its formula. If L is its length, B is its breadth, then L into B is its area. Since it is a 2D figure, so we find only the area. But here we have a 3-dimensional figure. So it has a volume. Now how to find its volume? Simple, as a cone. If we draw its height and let it be h, then just multiply this h with the area. Now it became the volume of this cuboid. Similarly for the cube, take a square and make its height h or anything, but since in a cube everything is same, its length, breadth and height, so its volume is L cube or A cube, whatever. Because for cube the length, breadth and height are same, right? And now let us quickly understand about the surface area, because we have touched the volume but not the surface area. So I think many of you have already understood that how the formulas of this surface area came into existence. See, for cuboid, this is a cuboid. Now how many faces it has? 1, 2, 3, 4, 5 and 6. 6 faces are there, and each face reflects a rectangle, correct? And what we are trying to find out is the surface area. So how its surface is looking like? It is a rectangle and nothing else, right? So if it is height, it is breadth and it is length, then similarly it will become the length, it is length, it is length, it is breadth, it is breadth, it is height and it is height. Okay, so to find out the area of this side, what we need to multiply is h into b. That means if we multiply this one with this one, then we will get the area of this side. Similar area will be of that side. That means let us multiply it with 2 plus. Let us take this side. To find out its area, we need to multiply L into B. And since the area of this side will be equal to its opposite side, multiply it with 2. Similarly, the remaining one. The remaining one means the front face and the back face. So to find out the area of front side, we need to multiply L into H. L into H. And similarly, the area of back side will also be the same. So multiply it with 2. Now, we can take 2 common. If we take 2 common, then what we have inside? HB plus LB plus LH. This is what we have as the surface area of cuboid. Similarly, will be the surface area of cube. But now we need to understand about the remaining 2 figures, that is the cone and the cylinder. And for that too, we need to understand the surface area of cylinder first, and after that we'll look forward for the cone. So now let me quickly draw a cylinder for you. This is a cylinder. Here we get 2 types of surface area, right? One is total surface area, which is the entire outer surface of the cylinder, and one is curved surface area, which is only this part, this rounded part. Okay, so to find out the total surface area, we first need to understand that which type of surfaces does it contain. Here I can clearly see one circle and another circle, and we all know the area of circle, right, which is pi r square. And since here there are 2 circles, so we will multiply it with 2 pi r square. Okay, but by this we are getting only 2 surfaces. One is this one and one is this one. What about this rounded part? So how this rounded part looks like? It is like this, like a circle. But the problem is that we don't need this part. We need the boundary only. And what is the boundary called? It is nothing but the perimeter, right? And perimeter of circle is 2 pi r, right? But if we will take 2 pi r only, then this part will not come. And what is this part? This is nothing but the height of the cylinder. So we must multiply the height. Now, if I add this with this one, that is 2 pi r h, and if I want to take common, then I can take 2 pi r, and now the remaining one r plus h. This is the total surface area of a cylinder. I think it's clear to you. And now the curved surface area, it is nothing but 2 pi r h, that is only the rounded part, right? That means only this part. This is the curved surface area. Hope you understood this. Now let us quickly jump into the cone. Let me quickly draw a cone for you. It's a cone. Now here I already said that it is regarded as 1/3 of a cylinder, right? And by this we saw that how its volume came. So let us dive into the total surface area and the curved surface area of this cone. So here we are getting one circle, that means pi r square, area of a circle. Now we got the area of the base, but what about this curved area? We need to find out that too. So for that, if we take it out from here, this part, and just presume that we are cutting it down to very small pieces. These pieces are so small that this curved part will look like a straight line. Just imagine this. But here also, this part remains S, and since this one is a circular part, so here we can apply the circumference of a circle. And what is that? It is 2 pi r, right? Since r is its radius, that is why. So now if we individually look into each part, it may look something like this. Very small pieces. Okay, something like this. And if we join it together in an interjecting way, that means one part like this and another part upside down like this. And similarly, if we keep on joining these parts, then we will get a rectangular shape. The figure thus formed will be a rectangle, right? But here also, this is S, because what is this? This part. And to find out the length, we need to focus here. See, it is 2 pi r, but here the thing is half part remains here, half part remains here. That means it is also 2 pi r. But to find out the length of this rectangle, we need to focus here. See, when we had the base, it was 2 pi r, okay. And if I tear it apart and just roll down on a ground, then we will get a straight line, which is 2 pi r, okay. Just imagine that I have cut this part from here and I got a straight line laying down here. So its length is 2 pi r. But here the thing is, half part remained here and half part went to the upside, because we have made this figure by interjecting each pieces. That means it will become half. That means half 2 pi r remained here and half 2 pi r went there. Now cancelling out 2 and 2, we get pi r. And what is the area of a rectangle? L into B. Here length is pi r. And what is its breadth? S, pi r s. So if we add another area pi r s, then this is nothing but the total surface area of a cone. Hope you understood this. And curved surface area, this is the curved surface area, CSA. Now we will look into the last figure, that is a sphere. Let me draw a sphere for you. This is a sphere. And since earlier I told you that a sphere is presumed to be made from 4 circles. So from there you can make it clear that the total surface area is equal to area of 4 circles. And what is the area of a single circle? It is pi r square. just multiply it with 4. 4 pi r square. This is the total surface area of a sphere. Now, many of you might get confused that then the total surface area of a hemisphere must be 2 pi r square, because if a sphere is regarded to be made up of 4 circles, then hemisphere is half the sphere. So, it should be 2 pi r square. No, see it clearly, 2 pi r square is only this part. But here we are getting one more circle upside. That is why area of one more circle will be added here, and finally we will get 3 pi r square as the total surface area of a hemisphere. Hope you understood so far. Let's meet in a next exciting session. For now, keep on revising these things, and if you will study like this, then be sure you will never forget these concepts in life.